So now that we know the rules for limits to infinity as they pertain to polynomial functions, particularly rational functions, let's take a little bit of a deeper look at the algebra behind those rules. For instance, we know from an earlier example that the limit as x approaches infinity of this 6x squared plus 3x minus 19 over 2x squared minus 11x, we know that's 6 over 2, which is 3, because we take the leading coefficients of the highest powers when the powers are the same and simply put them in a ratio. Now, can we actually prove that? In order to prove that, here's what we're going to do. We're going to take each term and divide it by the highest power variable. So the highest power in here is x squared. So I'm going to divide every single term by x squared. Divide, divide, divide. And what we're going to be left with here is 6 plus 3 over x minus 19 over x squared over 2 minus 11 over x squared. Now remember, we are taking the limit as x approaches infinity. We know that as x approaches infinity, any fraction where it's a number over x is going to 0. That's not up for debate because x is going to get large, so it's 3 over a large number. That's going to consistently approach 0. So is this, and so is this. So when we take our limit logically here, we end up with just 6 over 2, which is 3. Let's try and see what happens when the powers are a little bit different. So here I've changed the 2 in the numerator power to a 3. So we know that this answer is going to be positive or negative infinity, and we're not going to negative infinity, so we can reasonably conclude that this is just positive infinity. Well, let's prove it. We've got 6x cubed plus 3x minus 19 all over 2x squared minus 11x. Now we're going to divide it by the highest power once again. Now there's two ways we can do this. We can either do this by the highest power in the entire function, which would be x cubed, or the highest power in just the denominator, which would be x squared. Either way is fine. Let's do the x cubed. So now we're going to be left with 6 plus 3 over x squared minus 19 over x cubed all over 2 over x minus 11 over x squared. Now we know that all of the fractions here where it's a number divided by a variable are going to approach 0. So we just have 6, and the denominator is going to approach 0. So we have 6, and then this is approaching 0, which we know will lead to a limit of infinity. Let's take a look at the third case. Where the larger denominator is in the larger power is in the denominator. So here we have the 3, here we have the 2. Again, the limit as x approaches infinity, 6x squared plus 3x minus 19, 2x cubed minus 11x. We're going to again divide this by x cubed. So we've got 6 over x plus 3 over x squared minus 19 over x cubed to 11 over x squared. Again, all of the individual fractions that are a constant over a variable are just going to approach 0. And we're going to end up with a 0 over 2, which is just 0. So the only one here that's somewhat nebulous is the second example, where we do still have to think about what happens as we approach a value, right? Because otherwise we end up with a denominator of 0. But in all other cases, we just end up with numbers. So this is kind of a decent way to prove this algebraically, rather than just having the rule memorized.